Hey guys, in this video I'll be showing you how to use the bracket method to find the root of a function. Before we move on, I recommend that you create this table here just so that it becomes easier when you want to fill in the values later along the video, or you can also download this Excel file that I've shared in the description below. And so this Excel file has all of the complete workings here, along with a chart to help visualize the bracket method. But I do recommend that you still follow this video to understand where we got those values from. So moving on, we have our problem here, and we're asked to find the root of that function. We're given our bracket method formula, and here is where we have to input our initial guesses. So let's start by doing that. So an initial guess is basically our own hypothesis or estimation of where we think the root of the function is. And so let's just say, for example, I choose here 6 and 5. This means that I'm hypothesizing that the root of this function here is anywhere between 6 and 5, meaning it could be 5.9, it could be 5.8, 5.7, 5.2, and so on. The thing is, with the bracket method, we have to be a bit smart when choosing the initial guesses. So here 6 and 5 is still totally wrong, and it's because if you look here, we have two of these green values. Now what do these green values mean? Here f of xu is simply just the evaluation of this function here using the xu's, meaning we're replacing all of the x's here with 6. This is the same thing here for f of xl, where we're replacing all the x's here with 5. Now, the green here means that these values are positive. But the thing is, in the bracket method, when we evaluate these functions, we want one evaluation to be positive and the other to be negative. So in this case, this won't work because we have a positive 24 and a positive 14. So we have one positive value which can stick. So let's keep our first initial guess of 6 the same. Now let's try to change our 5. Right, so if we change this to 7, it becomes a positive 36. Changing it to 8 becomes positive 50, which is even greater, which tells us that we have to go down. So let's start again with 5. Let's move on to 4. Let's move on to 3. Now 3 here is 0, and meaning if we go down further, it will be negative. So let's try a 1. Okay, 1 here produces a negative 6, meaning that that evaluation is already negative. Since we have one positive evaluation and one negative evaluation, we can move on to the iteration table. And again, I will be explaining the logic behind this later on towards the end of the video with our chart here. Okay, let's go back to the iteration table. Let's first start off by inputting the delta x value. Now delta x is our bracket method formula, which is shown here. So let's do the following. So it's simply the x upper here, and let's $sign this, minus the x lower, again $signed, divided by k. Now k is the number of iterations we're doing. In this case, we have 24 rows of iterations, so we divide this by 24. Again, you can do 100 iterations, 1,000 iterations, that's up to you. And typically, the more iterations you do, the more accurate the result would be. But in this case, 24 is enough. Let's press enter. And the reason why I $signed it is because these initial guesses will not change, right? And so this is basically a constant. So what you can do is just highlight all of this, Control D, and copy it down. Or you could just drag your mouse down. Okay, so we have that done. Let's move on to XU. Now XU is simply just our first initial guess here, right, of 6. Again, reference it to our cell here, just so that if we want to change our initial guesses, it will also change in the iteration table later on. So press enter. Now XL, however, is not the same as we did for XU. XL requires a formula. Now XL in this case is our XU minus our delta x here, like this. Okay. Now f of xu is simply the evaluation of this function here using the xu value in the table. Again, it's simply just 6 squared minus 6 minus 6, like this. Now f of xl is the same thing, so just Control C and Control V. Okay, now let's move on to the second row of iterations. Here, xu is simply just our xl value from the previous row. So reference it to that, and from here it gets very easy. We can just highlight all of this and copy it down here. And we can do the same thing until the end of the table. So highlight all of this and Control D, or just drag it all down with your mouse. Okay, now this is basically the bracket method. We finished all of our iterations. Now from here, how can we find the root of the function? Now, one limitation of the bracket method is that it doesn't actually tell you where the root of the function is, but it tells you a very close approximation or position of where the root of this function is. Now, just to tell you, the root of this function here is x equals 3. And so how do we know what the root of the function is using the bracket method? Well, it's when there's a sign change with the evaluations of f of xu and f of xl. So previously, all of the evaluations gave us all positives, right? Positive, green, 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 it's all positive. But if we look at row 15, there is a positive and a negative evaluation, which tells us that the root of the function is anywhere between these two values here. So it's anywhere between, let's just highlight this here, it's anywhere between 3.08 and 2.875. As I told you before, the actual root of the function is 3. And so what the bracket method tells us is that the root of the function is anywhere between that 3.08 and 2.8. Now, if you did up to 1,000 iterations, the answer could be very specific. So it could be, for example, 3.0009 to 2.9999, which would tell us exactly that the root of the function is 3. But in this case, we just figure out that the root of the function is in between these two numbers here. Now, let's try to change our initial guesses. We know that this is a quadratic equation, and a quadratic equation has two roots, right? And so we figured out the first root. Now, what is the second root? Simply, we can just change the initial guesses. So let's change this to -6 and -1. And we find out that the second root is actually here, right? So when we observe a sign change, ignore the yellow highlight above, is here, because we observe a sign change, and this tells us that the second root of this function is anywhere between -2.04 and -1.833. And the actual root of the function is -2. So the bracket method has told us where an approximation or estimation of where the root is, which is in between these two numbers. Now, going back to my previous point of why we have to evaluate at a positive and negative evaluation, let's look at our chart here. So let's move on to chart 1. So basically, when we're iterating, 1 is positive, 1 is negative. As we go down here, we reach a point at the x-axis where 1 is positive and 1 is at the negative, right here. And the reason why we look at it this way is because when we want to find the root of a function, we're looking at a point where f of x equals 0. Now, what do I mean by this is, let's take, for example, this quadratic equation, right? If we did this manually and we wanted to figure out the roots of that function, we would do something like we did in school, where we would take x squared minus x minus 6 equals to 0, right? And then we would move the x's around and we would find the root from there. Now, this is exactly what the bracket method is doing. So it tries to iterate until a point where 1 is positive and 1 is negative, like this, because it tells us that at a certain point, it would be at 0. And when f of x is equals to 0, that's when we can find the root of the function, right? Which is visualized here, right? Again, 1 is in the positive y-axis, 1 is in the negative y-axis here. And between this, we eventually reach f of x equals 0, which is the root of the function, which is why we had to do what we did previously. Okay, so that is it for this video. I do have some other tutorials on different numerical methods, such as the fixed point, false position, Unit-Raphson, and so on. So if you need to, please take a look at those videos as well. Thank you for watching.